Hello, everyone, and good evening from London. Welcome to the fourth edition of the Talk Surgery series hosted by Surgery.International. We now have at Surgery.International 18,000 subscribers to our newsletter and online platform from over 140 countries, including consultant surgeons around the world, C-level executives from medtech companies, and a whole host of other people who are joining our platform to share latest news and share the interest and passion that we have for the world of surgery. So do please register. And thank you for joining us from wherever you are. Today, we have over 500 registrations from over 100 countries. So thank you for joining us for this amazing session on AI in surgery. I'm so pleased we're covering the subject. We covered the digitalization of surgery in the last webinar. I felt there's time to cover this important subject of AI in our profession. Much has been happening, you may have seen, over the last few weeks with the launch of the latest version of OpenAI, with Google launching their Gemini series, the latest updates, Microsoft their Copilot, and of course, the interest people have globally on large language models. Surgery has been analog for a long time. Now we're entering the digital world. We've gone from being an analog surgeon to a digital surgeon in a matter of a few years. And the future looks very interesting and exciting. And we have a really world-class panel today, which I'm really excited about, sharing their experiences, how they're building the products for AI, and what the future might look like. So let me go around the room and ask them to introduce themselves. We'll start with Dr. Sandeep Sarkar.
Thank you, Shafi. I don't count myself as one of those great visionaries of AI. I'm a jobbing, humble vascular surgeon who back in 2016 realized that my patients might have a better quality of life after they've come to me, if they're lucky, but actually they don't live as long as they would have done had I just done a big operation and removed one of their legs. And that led me to wonder, is the vascular surgery really what I want to do for the rest of my life? Am I actually helping people? And I was very fortunate to make a blue sky thinking application to capital enterprise through Bart's Life Sciences and Bart's Charity to use a natural language processing technique to code the whole of my diabetic surgery cohort to try and work out the simple premise of who's going to get worse with their diabetic foot disease and who do we need to concentrate our efforts on. I was standing on the shoulders of the giants that I was very fortunate to be able to get to do this work for me. And lo and behold, I've stumbled somehow into clinically using this in a triaging application, and which makes so many people so interested in this project, an AI project that I actually can use clinically to find the patients that we're most worried about. So really, I feel a bit of a fraud. I'm the person who might have thought something, and then when I said, can it be done, everyone around me just said, yes, it can be done. And so I know a little bit about AI in a world where most of us in surgery know very, very little indeed.
Thanks, Sandeep. And we'll be exploring your thoughts on the work that you've done, which is groundbreaking in terms of using AI for surgical diagnosis and diagnostic, which is amazing. Talk about kind of diagnostics, talk about the back end. Obviously, industries work together, and I've always thought of the world being one of convergence and collaboration, the two C words I often use when I give a talk. And what's been good recently is we've seen industry partners come together with surgeons, with our surgical fraternity, to build the future of surgery. So it gives me great pleasure to introduce Thomas Knox, who I've met over the last few weeks. And I'm absolutely intrigued by his history of what he's done before and what he's bringing to the table to revolutionize the OR. Thomas.
No, Shafi, it's an absolute pleasure to be here. And Sandeep, you were talking about feeling like a fraud, man. Sitting in this room with the titans such as you guys, I am more than humbled. Yeah, pleasure to meet everybody. My name's Thomas Knox. I am the CEO of Vitveo. Yeah, a bit about my background, kind of what Shafi was alluding to there is over the last decade, I've had the pleasure of helping build quite a few hypergrowth startups in different industries. I mean, ranging from, travel to autonomous stores, actually. So if you guys have ever heard of like Amazon Go or Amazon Fresh, as it's called in the UK, I actually was an executive at the biggest competitor to them that actually has surpassed them in the number of autonomous stores. and most of my team actually is as well. So now what we're doing is actually taking a lot of that technology and that knowledge and then pairing that up with amazing surgeons and amazing clinicians, hospitals, et cetera, who are really forward thinking and saying, hey, we don't have to be, medical professionals, or we're under no delusion that we're medical professionals, but what we can do is come in as technologists and pair with you guys to understand the intricacies that you're handling, but we can handle the technology side and really figure out how to solve those problems. So super excited to talk with you guys today. It's very exciting. Thank you very much.
Thank you, Thomas. And we'll explore the data side of things, what you're actually building to make it safer in the OR using AI as the back end. And of course, Serco Pelzel, who I've met over the last few years, and I've been intrigued by his work. I mean, actually revolutionary. I mentioned earlier that we're becoming analog to digital, and he's actually built a company that really is a forefront, a cutting edge of what digital surgery looks like. And I mentioned surgical navigation that might change the future, aiding, assisting us. Serco, welcome, and thank you for joining us on your busy schedule. But tell us a bit about yourself.
Shafi, thanks for inviting me, and yeah, best wishes from Hamburg, here from the north of Germany. Everybody knows Hamburg is just on top of Berlin, second biggest city in Germany. Yeah, very happy to be here. Yeah, what do we do as Apocular? We create the so-called holomedicine platform. We're now in above 70 big hospitals, do quite a big 5G implementations, and I think AI is one of the most important components. Now, very important always the whole certification process. Now, when we speak about navigation, how to certify it, how to clinical validate it, I think that is one of the biggest challenge in this whole development process. But yeah, happy to speak more about it, and handing over back to you, Shafi.
Thank you and welcome, and thank you for joining us from Hamburg. We have a truly international feel. Now we're going all the way to the US for our chief agitator, I call him in AI. John Nosta requires no introduction. He's a global, famous rock star, if you like, in the world of medtech innovation and AI. So John, a bit about your background for the audience.
Sure, it's a pleasure to be here. I'm looking forward to jumping in. My brief career in medicine was in cardiovascular pathophysiology up at the Brigham and Women's Hospital in Boston. But the bulk of my career has been a keen observer of the world of innovation, but a little bit different, the diffusion of innovation. My interest is why ideas take and why ideas don't take. And that's sometimes as critical as the innovation itself. So that's been my principal focus for the past 3 or 4 years. I've really honed in on the application of artificial intelligence, particularly large language models, not only in medicine, but in the broader reality of society. So I guess in the final analysis, I've become less of a provocateur and more of a philosopher these days, Shafi.
Well, thank you very much. Rather than agitator, philosopher, I'm okay with that.
No, okay, I take it back. I take it back. I changed my mind.
No, thanks so much, John. I'd love to hear your thoughts, of course, on this topic. So the audience, thank you for joining us. More of you joining us as we speak. So we'll be having a conversation for about 40 minutes. Then we'll be going over to you for a Q&A. So on the chat, please do have a conversation with us, ask some questions. I'll come back to that at the end to ask our learned experts here and pose those difficult questions to them, hopefully. We'll start with medicine and surgery as a whole. And sadly, of course, you're a practicing clinician, you're a vascular surgeon working at the Royal London Hospital, but you're the cutting edge of AI. Tell me where we are with AI in terms of research, application, from a scientific perspective. Because often we talk about AI and LLMs, it's very attractive, but actually we need to have fundamental science based on that to make sure that it works properly. And, clinicians need data to ensure that what we're doing is the right way forward. So tell me about your thoughts, Sandy.
Yeah, so actually it's still somewhat in its infancy, even though perhaps research was the first real element which in medicine that was using AI fully. So the more mature elements of AI use in research is for trial design, recruitment and selection of patients or selection of potential patients for clinical trials, coding of data and results for research. And now more and more we're moving into the AI uses to look at all of the research outputs that we can now pull out even without really understanding what the research outputs are. So in the world of genomics, to metabolics and proteomics to some extent, actually, do we really understand all of the outputs that we're seeing in research, and are we missing valuable data? So those are the kind of general areas in research that we're going to, and of course, the very basics of research is the use of good, reliable data and the use of AI tools to ensure clean, reliable, standardized data is the other element, which of course is the same as for what we want in clinical medicine. So those are the big general areas in research.
Yeah, so we're kind of very early on, and you're kind of trying to understand it better. Tell us a bit about your specific project. I'd love to kind of go into more detail, exactly what you're doing with the diabetic patients and how you think that might impact the outcome.
Sure. So, of course, where do we think that AI is going to be useful and important? Well, you know, there's those mundane things that no one wants to do. There's those things that people could do, but actually it'll take too long to do it. But one of the things is the things which are so complicated, with so many people having so many thoughts, views, ideas, anecdotal evidence, that you can never actually come to a decision on the perfect pathway for a patient. And I treat patients like that, who are usually diabetic patients with complex medical needs, multi-system involvement, but we involve multiple disciplines to deal with their particular organ. And the number of times I sit there in an MDT where I have a nephrologist demanding that this patient is taking an ACE inhibitor, whilst at the same time I have a diabetologist saying that they definitely don't want that and they want this instead. And who's right and who's wrong? What's the right pathway for complex patients who've got multiple comorbidities? They're older, they're frailer, and we want to do big things to them with a knife where they lose lots of blood. And so the answer would be, of course, to look at all of the data for all of those patients in their clinical histories and their examinations and their backgrounds, and use that to come up with a meaningful pathway answer. And then, of course, you can't really do that, because if you do linear regression on every single element of every single patient, then of course what's going to happen is by luck you're going to find some associations, and then suddenly you've changed everything. So what I wanted to do was use natural language processing to extract the coding for everything that anyone has ever typed into the electronic health records, and in so doing, I've managed to identify the diabetics. I've managed to identify who may have diabetic foot disease, and I've managed to stratify who may have bad diabetic foot disease. So far, all I'm doing is I'm identifying those patients in order to treat them early in their progress in this disease process, and that has some health benefits and an increase of longevity and increase of having legs for longer. But the ultimate aim, of course, is to get the coding for everything just right, so we can actually see exactly which way patients are going and how to intervene early in the right way. Which pills should they be on, and stop this massive epidemic of major limb amputation. So that was my idea. Of course, so many things come from the sides of that, but that's where I'm trying to aim for in the end.
Thank you, Sandeep. And you've actually asked one of the questions that we've always asked ourselves. So for those in the audience who may not know already, we often say the most difficult decision made by a surgeon is when not to operate. I heard Sandeep talking about the whole concept about using AI data to understand pathology and resist the temptation to operate or delay it as long as possible, possibly making surgery redundant in the future. We'll come back to the moment, of course. I know John will discuss that as we go forward. It's all about data. And obviously data has to be coded properly, has to be accurate to make it work. Now, Thomas, your whole world is around data. That's kind of what you do for a living, right? You've done that for other companies, including these autonomous retail stores, for example, and now you bring it to the OR. Tell us about what you're doing in the OR currently and your vision around how AI will help us to become more efficient in the OR.
Yeah, absolutely. I mean, Shafi, we hear every single day about these massive backlogs and the overwork of staff and so on. And it's absolutely crazy to me that the idea that staff still have to operate with an EHR by hand, but I expect that's not going away anytime soon. But what we're trying to do is take kind of the first step here, which is essentially we go into surgical operating theaters and we deploy, let's say, cameras and sensors into the OR to start tracking all the people, equipment, fixtures, fittings, processes, et cetera. Once you have those tracked, you can use the context of like who's doing what at what time to understand things like the stage of the surgery. So like, has a patient arrived? Have they gone under anesthetic, first incision, so on and so forth. Once you have that context, you can do things like understand the runway till the end of a surgery. And when you use that, then you can start like using that as a context to trigger actions around the hospital and communication. So like when you're getting to the last 20 minutes of a surgery, trigger off to let the preoperative nursing staff to start prepping the next patient, so on and so forth. The idea of this is all coming back to reducing backlogs, as you guys know, 8 million people in the UK, so it's definitely a major topic at that moment, but also to try to make things just a little bit smoother and keep people focused on what's most important, which is the patient. I mean, if you have a patient on the operating table, I don't think the most important thing is to be logging data into an EHR when we can do that automatically. Now, this is not an easy transition. It's going to take a long time for us to get there, but nonetheless, we're starting to see like, when I first went into the healthcare space, people were telling me you're absolutely crazy, that things don't move quickly here at all and it's impossible. But already in just a couple months, we're a company that's under a year old. We're already talking to some of the biggest hospitals in the world and moving forward with them. So I think there's a bit of a shift. And to be honest, I think that happened after COVID. Because I think after COVID, people realized the way that we've been working previously isn't going to work anymore. And we need to start adapting to that, especially since there's been a big migration of medical staff leaving the industry. So it's been, the pressure has never been higher on this. And the idea isn't to like, we get this like question a lot, is like, are you going to be like micromanaging a surgeon or something like that? No, that's not the idea. That's definitely not what we're trying to do. It's instead trying to kind of, let's say, autonomize and let's say like trigger the communication methods around the OR, just make things go a little bit smoother. So when you wheels out a patient, your turnover is finished, the next patient's being wheeled in right when they're expected to, not having this like death by 1,000 cuts and delays throughout the day, which has a lot of benefits added to it more than just reducing the backlog. We've also seen, heard some really amazing stories from some of the hospitals that we're talking to, where if you were to implement something like this, you can actually help retain staff and keep them a bit happier, because nobody enjoys logging data. That's not the most fun part of their job. One of the things that we work under as well is this kind of ethos is never add an additional step to the surgery, or you might end up on the operating table yourself. That's one thing that we're always working in, is how do we take steps away and make them do the job or the thing that they're specialized in, which is the patients.
Thank you, Thomas. So if you look at the journey of a patient, Sandeep is sorting out the pre-op diagnosis,
exactly,
risk stratification. He's then saying which patients could be offered surgery with the best outcome. So Sandeep's work is very much around the pre-op kind of stratification of risk, etc. Thomas is now going into the theatre to say, actually, we can make your theatres much more efficient. We're so inefficient in theatres, we know that. And so we could do better, particularly in the NHS and I'm sure other systems that are at fault. And we can do better, avoid complications, allow people to be safer during surgery. Now we move on to the preoperative part, right? The kind of the intraoperative and preoperative part of it. One of the things I often talk about is, as surgeons, we often, I think, in the operating theatre, we kind of have two things that govern our work. One is intuition, and second is judgment. The judgment is based on tens of decades experience that we've built up to allow us to do a safe operation, given the knowledge and insights of previous operations. That's kind of who we are. So that's really quite an analog. It's about us and how much work we've done and experience. Can we digitalize it? Can we be supported? I'd love to be supported during the operation. And that's where Serco's coming in. He's revolutionizing how we think about an operation. Serco, tell us about your work and what you built.
Yeah, thank you, Shafi. I think, first of all, I want to agree with Thomas about the workflow. Very, very important. Must be short as possible. And for us, we work with holograms. So we can upload a DICOM. It creates automatically a hologram, a CT, MRI, PET, SPEC. And I think it starts already with AI. If you do this in a hospital, you need to anonymize it, especially when you use a strong cloud. So you need to have a 3D anonymization that works with AI, for example. And then the second part is, okay, you do your planning, you want to do segmentations, you have AI again. And the best is you get a confirmation by the doctor. Otherwise, you don't have the MDR or all the other certifications, because if you run it completely automatic, you will be in the highest risk class and you will never get through the certification. And then indeed, the yeah, the biggest target is the superimposement, placement, guided navigation. And we are working hard on this since a long time. It's following me every day. We are releasing now the guided placement, so you can do with your fingers your own markers, virtual markers. You do it on your hologram and you do it on your patient. And the same as these fully automatic superimposement. No? So we are so far that you can have now, for example, they're testing, my guys like to test with my head because I have an MRI. So they can look at my head and then automatically with 2 seconds, it's superimposed, 1-to-1, right? And here you need also AI again to do it, to do point cloud mapping, cutting the scenes and so on. There's a lot of technology behind. But I think there's also the way of certifications. No? So this is, I think, very important to do the right studies. And there we are at the moment. But the technology is there. No? So it's not far away. And the dream must be, you look at the patient, it doesn't matter where you look at, you have it automatically superimposed in seconds.
And that's amazing. If you haven't seen their work, you should try experiment with it. It's pretty mind-blowing. I mean, they were there really early on in this whole journey of the digitalization of the OR with overlays, CTs, MRIs on the patient. But I mean, it's just phenomenal. That's stuff that really is kind of sci-fi. Not quite sci-fi, it's here today. One of the things that I've kind of noticed, Serco, is a lot of companies looking at computer vision, right? To allow us to navigate through a surgical procedure, taking videos, for example. It's quite difficult. Computer vision isn't easy in surgery, all right? So how long do you think it would take us to fully optimize that to where we could use it on a regular basis, do you think? How far are we off?
Yeah, I think the first step to automatic superimpose, it's not far, but then the next challenges are the movement, right? Yeah. Patient movement, the tracking. Yeah. And what I think, what we always, our challenge is we want to do it with one device. We don't want to have external cameras because we think it's too complicated. The setup must be easy. It must be, as a doctor, just take it in. And then the second one is, something like organ tissue movement, right? You have a brain shift in the head, open liver surgery, they have a movement. It says, set are the next challenges, no? And that is always AI behind. But I don't think, I think in 5 years, nobody speaks about it anymore. It's standard, right? This is for me.
Serco, just give me a call after this, you know, we can chat. I'll give you the cameras.
Okay.
Thomas he's not going to tell us what he's doing, but it's sort of top secret. But Thomas, over a coffee, we'll talk later. Now, of course, so we're talking about surgeons being automated, supported, making decisions, etc. Now, John put a tweet out the other day, and we had a conversation around the obsolescence of surgeons. So, John, what do you think? Are we going to be obsolete fairly soon in your mind, or should we become obsolete?
I think that the principal question is around the obsolescence of humanity itself. That's the bigger question. But I want to go back. When I was spending time in medicine, there was a joke. And, you know, there's a lot of truths in jokes. And the joke was that clinical practitioners knew everything and did nothing. And surgeons knew nothing but did everything. That was the clinical dynamic. And I want to address that because I think there's something interesting there. Analog to digital, Shafi, that's the path you've established, right? We're moving from analog to digital. I think that's not it. I think that you're missing another step. And it has to do with the idea of surgeons knowing nothing. And what I mean here is that we are moving from analog to digital to cognitive, because almost everyone has discussed surgical intervention in the context of not technique, not 60639 silk and a P3 cutting needle. They've discussed it in the terms of outcomes. What's the best decision? The hardest decision I have to make is whether to operate or not. It's not technique. In fact, I think that craft, the art of surgery, the craft of surgery is actually moving into the cognitive realm. Craft is being placed by cognition because the machines will do the mechanics. Let's face it. I mean, the ability to do fine motor skills and technology, I believe, is advancing to the point where it will supersede that of the clinician. So that's what I think. I think we're moving not from analog to digital to cognitive. And that's a big step, I think, in terms of medicine in general.
I love that quote, John, from craft to cognition, or along those lines. I think that's a great line. I think you're right. What we have discussed, we're not discussing the actual operation, which we'll come to in a moment, but actually what we're discussing is the decision-making around it, the automation, the efficiency, navigation, help us, aid us to actually do the operation. But John, here's the thing, right? There's robots coming out, many robots now, of course, assisting us. Of course, Intuitive brought out the Da Vinci almost over 20 years ago now and led the way. And now we're seeing a plethora of newly designed, smaller, modular, cheaper devices that are now becoming more commonplace. And at some point, they may even be more democratic and get around the world much better. So we are placing some of our technique also by robots, in actual fact, to assist us, support us. So we are now become digital surgeons in that sense, I guess, to help us do fine operations, get to deeper spaces, for example, allowing better visualization. So where do you think that sits, the robot, in terms of that whole cognition process, John? And do you think that's kind of the way we're heading towards as a kind of society where we'll have more automation?
No, I think that the fundamental expression of artificial intelligence and technology in general is artificially personified in the context of a robot. I think robots, because they take on a human form, make it feel like a natural extension. So I don't think you're going to see the robot walk into the operating room procedure. But I think that you may see other humans have expanded skills. So if I could use technology to prioritize low-risk patients, I can have a midwife deliver a baby. So I wouldn't be at all surprised if I see a fairly sophisticated, technologically trained technician, let's say, with appropriate computer augmentation, do a simple AP, do a laparoscopic appendectomy. So I think those roles are going to be changing fundamentally. I think to interchange the robot with the doctor is a step too far. Look, Shafi, we've had this conversation all the time about availability of resources.
Yeah.
Do I have access to care if I don't have access to a surgeon? So I think we're going to see the various levels of technical skills be augmented by AI itself, creating a hybrid surgical intervener that will redefine the role of the physician.
Thanks, John, for that. And we'll come back to that and discuss more about the LLMs in a second. But Sandy, back to you. The key thing is data, right? We've had trouble in the UK and other places collecting good data that's tagged properly to be able to use on the models, okay? So how do we go about changing that kind of paradigm where in the past, we've not thought about the data going forward and prospective data. Now we're almost chasing ourselves by doing NLP and other things to bring data back into the equation. What would you advise surgeons who are watching us, if they want to use AI, what do we do about the data? What are the key steps of ensuring that what we collect at the end is quality that can be used in a model, for example, or an algorithm?
Yeah, that's a huge question. Of course, again, going back to 2016, that was the Wild West. No one really knew what we were doing and why we were doing it, what we wanted to get from it, and how much approval is required to get that data in the first place. Whereas now we've been working for some years towards a sort of federated system of data approvals and data sharing, and the UK has its version. I think the European Union has just signed off on a Europe-wide data approval service and a data sharing agreement, but which we're not in as yet, but I think we probably will be. But I think for people around the world, most countries are now setting up their own data agreements. Now, on a practical front, what does that mean? I guess the first thing is that if you're going to do something using AI, just to touch on a point that was already made, you need to know what you want to do and why you want to do it, and make sure that it's something that's worth doing in the form that you're doing it. And then your next question is, what data do you actually need? Because no one's in the business of using data that they don't need, and there are stringent plans in place to make sure that data that's not required is not being used. So you need to really know what data you need, and in order to know what data you need, you might need to do some pilot work using dummy data, because you don't necessarily know what outputs are going to come from your work. And again, for example, in the NHS, we have new sets of dummy data. Well, I wouldn't like to say dummy data, real data, which has been depersonalized and re-anonymized, so it actually doesn't fit to individual patients. Then your next challenge, having worked out what data you have and having access to that data, is to make sure your data is clean, and to make sure that you're taking data that is correct and true and clean. Only if you have all of that lot can you really look at the prospect of doing a study, getting your ethical approvals in place, and your regulatory clearances in place. So you need to know all of that before you can handle data in the first place. And that's what I've learned from the work that I've done. And then what I consider impossible work, but data analysts will shrug and say, no, this is quite doable. The correct processing. If you throw every single technique at something, you may find something that sticks. That's not really the way. The correct processing of data, and then how do you actually come to a product that you can consider and use? Not necessarily a product, but it might be a device. The way to do that really is to have a training data set from that data, which is completely different, ideally, to your implementation data set, which you're going to use for honing and validation. And currently, most of the systems that are in place for the use of data in AI techniques requires feedback loops for constant validation and improvement. And it also, at the moment, really requires clinician validation, unless you're a signed off medical device using AI technologies, which there are not many of as yet. You really need to still have a process whereby a clinician is actually verifying what's happening as well. So that's the whole system required at the moment, I think.
Thank you. That's good in terms about tagging, doing the process correctly, etc. So many things you have to get right, and then do the pilot, and then move on to a bigger study. And I kind of get that. So it's still early. We're still moving forward. But I think there's huge, of course, interest now. And there was a paper in the Nature just last week around AI in surgery, looking at pre, perm, post-op kind of outcomes. I'll come back to you, Thomas, for a question.
Yes.
So, AI, there's the issue about safety. All right, people worry about, and we had an AI safety summit here in the UK at Bletchfield last year with Rishi Sunak bringing a host of governments in. So from your other work you've done for other companies, other industries, how should we go about ensuring we're safe? What do we need to do in terms of being reliable, honest, and making sure that we do the correct thing for our patients? So safety is huge.
Thank you, Shafi, for throwing me under the bus here. No, there's no easy answer to it, to be honest. And I think, honestly, just to come back to Sandeep's point, actually, I wanted to add just an additional piece to that. What we're doing at Vithya when we're tracking, the movements of the people, the actions that they're doing within the operating theaters using computer vision and AI. One of the things that we started to do, like, data is still a problem for us, but one of the things that we've used to kind of bypass a little bit of the challenges of getting that data is initially starting with something that is non-clinical. So looking at the operations, right? Looking at how do we make the ops more optimized, because that's something that you don't need to be classified as a medical device. However, a lot of the data that we're capturing there, and this is where it comes back to the safety point, Shafi, is that in time, that data will allow us, like, once you have those cameras installed and these sensors installed, you're capturing context. You're creating like a baseline data layer, right? And that baseline data layer, you can start to build feature sets on top of that and other models that can help with different things such as safety. Now, one of the big things that we often get asked about is, there's a big thing, like the state of the art in the UK is like scan for safety. So like scanning the trays and checking, doing counts and things like this, right? Now, one of the things that we've been, tasked with, and we talk about a lot with the hospitals that we're talking to, is can we do counts? Like, can we count make sure that nothing was left in the patient? And actually, I'll give you an example of this. A couple weeks ago, kind of all couple months ago, we were actually scrubbed into a surgery, and we were watching this as laparoscopic surgery. They went in, they left something as they were like pulling out, they were doing the count, and they realized they left something in the patient. They had to go back in. Now, this is something that they didn't realize till like all of this was finished. Now, what they want to try to do is try to detect that automatically. We're still a bit away from that. And for example, I can't go do that today because it would be considered a clinical, like a classified as a clinical device. And for a startup to go into that, it's really, really difficult because it takes years of effort to go get your device certification. Every new model that you do takes you have to go through the whole certification process again. But you start with the non-clinical data, and then you grow that into the clinical side slowly, piece by piece, adding these in, trying to find the pieces where, starting with the easier bits, right? And I really think, I want to touch on something Sandeep said as well, which is how important it is that towards the beginning to view these things not as a catch-all, like AI is not a catch-all that's going to solve everyone's problems, but instead to use it as a tool that augments to move a little bit quicker and to give you more confidence. So maybe you're doing a count, but instead of double checking, that this also is giving it, so it's helping you just speed it up a little bit so you can feel the confidence on the decisions that you're making and the process that you're going through. And I think that that's the only way that we get the data sets that we need and to get to those like aspects of safety that we really need to get to is to start with things on my side, for example, start in startups in general. I think starting with a little bit non-clinical, moving more into the clinical, acting as an augmenter, which then over time you build confidence that you can actually do it completely. Because there's one big difference. People are more accepting of a human making a mistake than they are of a machine making a mistake. You could have a machine that is guaranteed 99% accurate. And if it makes one mistake, nobody wants to trust it anymore. So the only way you get over that is by building confidence over time that it's actually helped stop human error potentially. And I think that's the stage that we need to get to. And to be honest, what we're doing at Vifio, where we're looking at the operating theater on a whole, we're not really doing the intracorporeal. We're not looking inside of the surgical zone and things of that nature. But we are talking to companies and potentially partnering with us, because I think the ultimate like vision to where we get to a really safe surgery is where you let's say take all of these different layers. You look at the intracorporeal, you look at the intrasurgery zone, you look at the operation room on a whole, and you add all of these things together, and you look at the robotic surgery. And when you take all of that data, and again, it's not, you don't boil the ocean, so you need to take it piece by piece. But when you start putting those little pieces together over time, it adds up to a lot. And we just have to, take it step by step and don't expect things to be solved tomorrow.
Sure. No, thank you for that. And I'm really glad you put us where we are and being realistic about where we are now and where we might be in a few years' time. Serco, we talked about operations. What's the lowest hanging fruit? Which operation in your experience? By the way, Thomas, you went to one operation and left something in the abdomen, right? I'm really sorry, 100%.
No, I've been in a couple of surgeries, but
I promise you, it's only a rare occurrence. Right? The case. Serco, back to you. You've seen a lot of operations where you do navigation. What's the lowest hanging fruit? Which operation? Is it orthopedic, neurosurgery, skull? Which is the one that you think we can use navigation most quickest? That would be the most lowest hanging fruit that we can see in the shortest period of time?
Yeah, that's a very good question. We get requests from all of these medical fields. And at the moment, what you see is the intent of use is mostly still surgical planning, right? To go intra-op. I agree here with Thomas again. Sorry, Thomas, about start small and increase it. Otherwise, you get completely lost. But what we see is, the most important is to start perhaps with the areas which don't move, right? Which are fixed, like a neurosurgery, maxillofacial. Then, because, visceral, I think it's very complicated. In the moment you open it, it's moving everything. So it's the static things, and there you should start. And that I think is important. But
So fixed operations. So spine might be one. The skull-based surgery, max.
Yeah, skull-based.
And what we do for living abdominal surgery is way down the line because things just move around the whole time, right?
Yes.
We leave things behind clearly all the time, which is a shame, right? John, I won't have to have a discussion without talking about large language models, ChatGPT, AI, and where we are. And you've been doing a lot of work, a lot of writing. So by the way, everybody, if you get a chance, do follow John on Twitter, on social media, and also through his blogs on Psychology Today. Really insightful, make you really think about the world we live in and what that future might hold. John, what are your thoughts around LLMs, ChatGPT, OpenAI, and perhaps our profession as a whole, medicine, and where surgery might be affected in some way?
Well, as I said earlier, and I think this really is the fundamental truth, is that we are moving now into the cognitive age, that we are shifting from the days of the mechanical advantage to the days of industrialization, digitization, and technology into a pure cognitive construct. And I say that because I think in a very, very interesting way, our brains are lonely. So I'm going to step deep into the philosophical realm here because our brains are extraordinary. Everyone knows, everyone in the medical field knows about the circle of Willis, the magic of the anatomical vascular protection the circle of Willis offers the brain. The brain is unique. It has tremendous amount of energy capacity, and it's optimized cognitively. In fact, unlike, let's say, lactic acid mediated muscle fatigue in a sprint, our brain does not have that capacity for fatigue in that sense of the word. Imagine you're on a phone call with a new relationship or something, and that call goes 1, 2, 3 hours. At the end of that call, you're actually refreshed. You're excited. You're enthusiastic. That's not a fatigue dynamic. Now, after thousands of years and this cognitive optimization that our brain has offered, it's still lonely until now, because now we have the perfect partner. And that perfect partner is mediated by large language models. And that is in part because of the essence of the communication. It's a language-based model. So I think that's the big news of the cognitive enhancement. But there's something else, just to kind of quickly wrap this up. We all know that it's faster, better. Everybody knows that AI can write probably a better discharge summary, can write it faster, better. But here's the interesting thing that I think is truly transformative that a lot of people are missing. It lets you enjoy the experience. There is a level of cognitive engagement that sparks the genius within, that allows you to talk about the proverbial zebra, that stimulates you cognitively. And I think that's very important, because the monotony of clinical medicine in many instances, particularly in the context of the electronic health record, has been a distraction. Technology in many instances, from a cognitive perspective, has been an obstructionist role. So what I think we're seeing with the large language models is faster, better, and then you enjoy it. And simply put, large language models is like Waze for cognition. Think about that for a second. It gets you where you're going faster. It gets you where you're going better. You avoid the cops, you avoid the accident, but you enjoy the ride. You enjoy the ride. So when you can interrogate a model about a hot abdomen or about a fever of unknown origin, you are engaging in this cognitive dynamic that's tuned to your creative frequency, tuned to your genius. And that's the magic of the LLMs today.
Fantastic. Very interesting. Thanks for sharing that, John. And always great to hear your opinions. I'm going now to the questions, actually, if that's okay, and start posing them. Here we go. So, Chalia Chandrasekhar, nice to hear from you. The first question is there a case for using open surgical operations as big data sets for AI in surgery? And I guess we've kind of explained that during the conversation. Using computer vision, people are now looking at lots and lots of surgical videos, trying to annotate them, label them, to see whether we can predict how an operation should proceed, and then perhaps help you with navigation intraoperatively. And there are a number of companies working on that. As Thomas mentioned, and also Serco, it becomes more difficult, it becomes clinical, it becomes a medical device. And so what they were doing is working on lower hanging fruit that don't require that same certification. But there are some companies out there working on computer vision videos. Sandy, you've got your hand up.
Thank you. I agree exactly with everything that's been said on that point. I think I'd like to make another slightly different point on it, though. If we look at medicine and AI, medicine and AI, a lot of the work has been on direct data, whether it be electronic health record data or DICOM data, or workforce planning data, reimbursement coding data. But surgery allows us some opportunities that the rest of medicine doesn't, and that is the sort of the tactility of surgery, the pressure points, the way tissues behave when you touch them and move them. I'm thinking of things like the plane that you're going to dissect down in an abdomen that has been entered 3 times already. I'm thinking of I'm thinking of chameleons. Yeah, you don't see a chameleon on a rock until it moves. And what surgery gives us is that movement. And in the future, you know, although we need to start with basic things, in the future, the kind of whole avenues of AI that are opened up from surgery are so much more, and hence also is why it's been so much more difficult, of course. I think the use of movement inside the body is going to revolutionize things like segmentation that we were talking about. I occasionally work inside the chest, and the aorta moves so much, the heart moves so much that if I'm trying to place stents very, very precisely, I have to do something to essentially stop the heart sometimes. In order to place that stent, what if we can use landmarks to actually predict that movement, so that actually what I'm actually looking at is something that's not moving at all? So I think those opportunities are even greater in open surgery. And at the end of the day, yes, is the answer. Those are the opportunities, but those opportunities are right at the very, very far end of AI, I think. It's the final outcome.
Thankfully, I avoid those major vessels like the plague and try to avoid them as far as possible, Sandeep. So that's why I look to you to get me out of trouble sometimes. All right, going through a list of questions. Shivam, great, nice to speak to you again. It's around the use of AI, using AI responsibly, as I mentioned earlier about safety and ethics. The question is really, how are we moving towards making AI more responsible? And what talks about the ethical morality of AI in surgery? And are there any would there be unintended consequences with inequality or even with transhumanism? So there's a big of a question there. So John, let me come to you for that one, John. What do you think about the morality?
I have a simple answer to that.
Ah.
Who will protect us from the bias and the risks of humanity? I think that the human construct in the clinical setting, surgeon, clinician, there are extraordinary biases there. We could look at the use of pain therapy stratified by ethnicity, and different ethnic types get treated differently for pain. So I think that's a bigger problem. Number two, who's going to manage medical errors? As was discussed earlier, we judge AI by the one single mistake it makes, which is antithetical to humanity, because humanity, it's fail, 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 and then celebrate when you've gotten to the top of the mountain. With AI, it's succeed, 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 fail, front page news article. So I think that those are contrived concerns that don't hold up to the reality of the situation. I think it's got to be contextual. Look at Shafi, look at Tesla. How many stories do you see about Teslas burning, catching on fire in horrible crashes? Well, I think you got to look at the flip side of that story and look at the safety record of full self-driving. So for me, that's the pushback I will give. Any innovation always carries it with it the duality of wonder and fear. It started with fire, our first technology. After all these years, as we've taken fire and we've controlled it and we've used it to transform civilization, it's still the leading cause of property damage in the world today. So if you want to focus on the downside, if you want to focus on the tragedy and the horror and the deaths of fire, we'd never light a match.
True, and I think you're right. I'd like to also add to that. When we're looking about AI, you're absolutely right. When things go wrong, they go wrong rarely. Again, there's a lot of publicity, as you've said, John. But actually, when humans make mistakes, we don't have the same kind of repercussions of a single mistake.
To err is human.
Yeah. And
right? Isn't that an interesting? Why is that the case? That's horrible.
Yeah,
in the context of surgery. Oops, that's your justification. Oops, ridiculous.
So we say to err is AI. We should change that paradigm and change the language maybe in the future. But you're right. We're comparing the AI to an imperfect person with data. We make mistakes. We're not reliable all the time. We get tired, and we've seen that before. So we're not comparing like with like here. We're comparing something to, so maybe what we should do is not have supervised clustering, but unsupervised clustering, unsupervised. So basically it does what it needs to without the biases inherent in our judgment. Anyway, that's a conversation, I think, for another day, but we can discuss that more.
Shafi, I'd love to add something if you wouldn't mind.
Yeah, please, go for it, Thomas.
Yeah, and no, because honestly, John, all I have to say is here. Like it's absolutely the point I was trying to make it. Like it's 100%, you know, people are judge AI way harsher than a human. And you know what I think the reason for that is? A, because it's not a human, so there's no, you know, feeling of emotionality, connection with it, so on. But I think it's also B, because we can actually see the way that it thinks. So you can ask it, why did you make that decision? And it'll tell you the unfiltered truth. Whereas a human, what we do is we filter the truth. We give what we want you to hear and so on. We mold your reality with our words, where an AI will not do that. An AI will just tell you exactly why it did what it did. And sometimes that's unsettling, because if a human says, I'm sorry, I didn't mean to, an AI doesn't say that. It says, I did it this reason. I predicted this was a different, like, for example, the autonomous cars, I predicted this was the best decision to save everybody in it, and it ended up actually hurting more people. So in this kind of context, I think that the clarity of its decision making in a lot of ways is actually harming it sometimes.
Yet we cling to the clarity of the decision-making process. And when AI uses aconventional or atypical techniques for creative problem solving, we see the emergence of things like hallucinations and confabulations. And we immediately want to lobotomize the LLM so that it cannot do that again, which is tragic. In a human construct, when desperate and unusual parts are put together, let's say in the form of art, that's called creativity. So I think that this is a very, very interesting area, especially when we move to higher level cognitive function and even something that I call technosentience, because clinical decision problem solving is very interesting. It's not as didactic as we often consider.
And I think
it's intuition, as Shafi said.
Yeah, 100% agree. And also on the question about the ethical morality of it, I think it's really important to realize that these are machines. They have no ethical morality. They have no concept of what is moral or immoral. They are trained by us on the data sets that we provide to them. So the point is, what we try to do is, like, let's say, bias our data sets in a good way that give them the best of humanity. So in reality, they should theoretically be less biased than us. Now, there's, of course, cases where this doesn't happen. Like, you know, there's a lot of famous cases where different skin colors weren't detected and things of this nature, which are definitely things we have to work against. But they're all a part of that learning process. And you get better at that learning process over time. And that's not the AI's fault. That's our fault. That's a human error on how we train the model to get to that point. So what we need to do is focus on correcting our human error so that the AI is better and less biased.
Thank you for that. Okay, question, Circa, a question for you. We've got someone called Wa'azza who's asking about doing a study on looking at the MRI of the knee. He wants to have an AI model to calculate angles and distances to see if that'll improve accuracy. Can your platform do that at the moment? Could you do that as a hologram and bring it into your platform? What do you think?
Yeah, definitely you can upload a knee, and you can also render it with bone, also the bone rendering, we call it. And the measurement tool, you have two. If you want to have it all automatically, yeah, you need to train a new AI, and you need a smart person who annotates it.
Yeah.
I saw also the digital twin question, if it should be a successful surgeon. It's the same what we do. We have, for example, we train one AI for so-called discovery of focal dysplasias in your head for epilepsy.
Yeah.
And there are just 3 people in whole of Europe who understands and finds them. No? Yeah. And this is for me already the copy of the person, right? If the AI model is annotated by this person, right? And this is, I think, important. It can be all done technology-wise. It can be done. We just need a good annotation and a good setup.
Yeah, thank you. So the answer is yes, it can be done. So you need to reconstruct the MRI CTs, perhaps have a look at Circo's platform and see if that can help you, looking at 3D anatomy, orientate it in the kind of virtual space and make the measurements. And I think that'd be interesting, actually, as a project to do. And perhaps you need to get in touch with Circo's team for that one. How do we engage stakeholders? Many people now involved in this process. How do we engage all those stakeholders together? So Thomas, in your experience, and Sandeep, doing your research involving lots of different partners. Thomas, again, what's been the secret of bringing people together?
Yeah, I mean, to be honest,
I mean, quick, we haven't got very few minutes, so.
Yeah, just to be honest and really quickly on this, I think it has to start at the highest levels, and it has to start also like just permeating through it. People need to start feeling the reality of this is coming, and that I really do believe that is starting to happen. But what I think is it has to start at the highest levels and then start to work its way down a little bit, because if the people at the highest are really against moving something forward, it's not going to happen. And that needs to get buy-in from the clinicians, so from the surgeons. You need to kind of build these different levels. So when kind of you do this top up, bottom down, top up approach, so on and so forth, or top down, bottom up, sorry. Approach to really building trust within the systems and doing it very slowly. So don't expect it's going to change overnight. Expect that you have to build the confidence over time. I think that's the only real way that we move it forward.
Thank you, Thomas. Sandy, what have you found about collaboration, etc.? When you only got 2 minutes, thank you.
Yeah, so less than 2 minutes. I think mostly in the research field, people are saying yes, let's do. But the way to convince people that they really want to get involved is small wins and quickly. So clean data already available, small wins and quickly. If you build a pathway saying, you know what, you're going to have outputs in year 1, year 2, year 3, year 4, year 5, that usually brings in your research stakeholders, and of course pedigree of having already done it. So that's why I'm only just starting to benefit.
Thank you. Last question I'll leave to James Rose. James is obviously part of the Confederation of British Surgery, and they help support our program here. So James, thanks for the question. Thanks for supporting us in our endeavour for Surgery.International and these webinars that we bring on a monthly basis. Mistakes, clinical negligence, informed consent. Can that be better with AI? Can we make it better to get consent that's informed, for example, dealing with the complications, etc.? Who wants to take that question? Sally, you're a clinician. All right. So
I guess as someone who consents, of course, forgetting to talk about important things could very easily be helped, couldn't it? But the consent process always needs a clinician, because it's that
do we need
emotion.
A human? Do we need a human? Could you not just go to ChatGPT and fill in the details and have a conversation with ChatGPT that could give you the consent process, say about the complications, percentage of complications? Because that's kind of all we do, isn't it, Sandy? Or is there more to it?
No, but I'm sure you take your patient and you look at their specific circumstances and tailor their issues, and you probably talk about what you do to allay those risks and reduce them as much as possible in the decision-making process. So it's more complex than that, I suspect. And at the end of the day, the reason you won't lose the surgeon is because there is an emotional human touch to these things. So I think of course they can help, but I don't think they can take over. We're running e-consent processes all the time at the moment, and that's what I note from those. Actually, someone coming and going, did you get it? And then you find that actually what's being asked is quite a lot more than what has come through e-consenting now.
That's right. So we have now very much in the UK invested on e-consent, electronic consent forms, which is a new novelty for us. It's a new thing. There's paper records before. We felt paper records were the right way forward. Now we've got e-consent, and perhaps the next step forward is e-AI consent. So watch this space. I'm sure that's going to be coming to us soon. Well, I mean, thank you for joining us. Thank you for all the questions and all the interactions on this webinar. I've been fascinated. I've learned so much, as I always do, from the stellar panel. Thank you so much for joining us, Sandy, Serco, Thomas, and John from around the world. Literally, it's global kind of panel here that you've got. Hope you enjoyed it. We've got next webinar in a month's time on surgical leadership. Things that I think are very important for us to deal with, and to ensure we build the future workforce and ensure we build the future leaders with the skills required to build that digital component that we discussed today. So join us in a month's time for Surgical Leadership webinar. Plus, thanks to everybody who's joining us today. So thank you so much.